Science made quantum leaps in 2017, most notably in space and in medicine. The one truly historic event was the simultaneous detection of gravitational and electromagnetic waves from the merging of two neutron stars, 130 million light-years away. The event, which occurred in August but was announced in October after extensive measurements and checks of all kinds, was hailed in the media as the $1,000,000,000,000 cosmic production of gold and platinum. It is true that the explosion, known technically as a kilonova, produced 100 Earths worth of gold. However, the most important aspect of the discovery was that, for the first time in history, a cosmic event was observed with visible and invisible light, from gamma rays to radio waves and gravitational waves. To understand the significance of this, we must recall that, for millennia, humans could observe and study celestial phenomena only with their eyes, and the visible light we see is a tiny fraction of all electromagnetic rays. In the 20th century, radio dishes and detectors of invisible light, infrared, ultraviolet, X-rays, gamma rays were invented, and we started to study the heavens with a large range of waves and rays. Then, in September 2015, scientists detected gravitational waves, a completely different window on the universe, but one that mostly detects mergers of big black holes. The hope was that the technique would be developed and become sensitive enough to observe other, more common, astronomical phenomena. And indeed, within less than 2 years, the merging of two neutron stars was detected, and this allowed for a simultaneous detection of its entire electromagnetic radiation, in addition to the gravitational waves it emitted, a truly historic quantum leap. In medicine, important developments, some of them potentially historic, occurred this past year. First and foremost, gene therapy became a real thing. For years we had been promised this new approach to curing various illnesses, but only this year did it become reality. Indeed, the U.S. Food and Drugs Administration approved the new CAR therapy, where immune cells are taken from a patient, genetically programmed to recognize cancer, then injected back into the patient to, in essence, become living drugs, replacing pills that would otherwise have to be taken for life, often with limited success. This CAR immunotherapy was approved after the successful treatment of two twins with leukemia. It represents a new and highly promising way of fighting cancer. Science keeps surprising us with developments and discoveries, even in areas that we think are well understood, and the past year has been no exception. Other gene therapies were also developed and approved, including one for adults and children with an inherited form of vision impairment that can result in blindness, and another for the treatment of certain types of lymphoma. As one of the leaders in the field put it, 2017 was a watershed for the whole concept of gene therapy. Another biomedical breakthrough was the successful addition of two totally artificial and previously non-existent amino acid pairs to the DNA of a bacterium. Indeed, while the DNAs of all living creatures, from bacteria to humans, consist of the famous H, C, G and T base molecules, researchers added two completely new ones to a bacteria, and made it work perfectly well. This could be transformative in the way novel proteins are designed to perform certain biological and medical functions in living organisms. Artificial intelligence is prompting both hopeful and fearful reactions from observers everywhere. This year, researchers showcased two positive and encouraging applications of AI, in medicine and in exoplanet research. Indeed, AI is now used to sift through huge amounts of data produced by scientific studies and databases to identify the best potential treatment for patients individually, based on the genetics of their tumors, for instance. AI has now also been used to uncover two exoplanets that had escaped the searches made by human experts. One last impressive development I would like to highlight relates to our region. A team of researchers from Japan, France and Egypt used cosmic rays to indirectly observe a previously unknown chamber in the Great Pyramid of Giza, near Cairo. When high-energy cosmic rays, protons and electrons enter our atmosphere, they produce showers of elementary particles known as muons, which can be detected on the ground. The analysis of their spatial distribution tells us about their production sites and their downward trajectories. One can thus infer the existence of an empty room, a dense volume, or other structures in various places above the detectors. This muon tomography method represents a new way of exploring archaeological sites and finding long-hidden pathways, tombs and artifacts, at least large ones. The marvelous thing about science is that it keeps surprising us with developments and discoveries even in areas that we think are well understood. Human ingenuity promises ever more astounding findings about our amazing universe. Nidal Gesum is a professor of physics and astronomy at the American University of Sharjah, UAE. Twitter @Nidal Gesum.